laser gun, laser gun, laser gun, laser gun,
laser gun,
laser gun, laser gun,
laser gun,
laser gun,
laser gun.
laser gun.
And welcome back to Devlog. In the last part, and in this part I work on the laser mechanic for Pep-Pellington. The laser mechanic is a mechanic that is going to be used in the Flying Factory level, which is a bunch of mechanical objects and hazards for the player. One of these is the laser hazard. The way this works is it has a beam going from the start to the end of the laser. This beam, if it interacts with a breakable object, an enemy, or the player character, it will kill them. If this beam is blocked by something, the beam will be cut off at where it's blocked by. The first thing I want to do is create a vector of arrays. This is going to loop through every single laser we need to fire for one specific laser. A laser is made up of individual multiple lasers that are being fired simultaneously. This gives it the ability to have parts of the laser blocked off by part of objects. For example, if there is an object blocking off the main laser at just one aspect of it or one part of it, then some of these rays are not going to travel as far as others, and this is going to give the visual effect of the laser being cut off as it travels through things and give the impression that the laser is not just one singular line, but it is a bulky mass of a laser. This is very simple to do. I have an int for thickness and a float for width. The int is going to loop through with a for_int function. This is going to run every single ray that we need to run through for this function, and the width is going to and the width is going to control how far out these rays go. This is very simple, just a for_int loop that is modifying the width with every single iteration of this loop, and it is also determining if the current I that we are on in this loop is odd or even. This will dictate if this ray should be on the left or the right side of the original ray, resulting in an array of multiple rays for the lasers. I then need to create visual effects for both the impact of the ray and the rays themselves that are going to be traveling along the actual laser to give it its visual effect of being a laser. I will touch more on this in the visual creation process, but for now I'm going to use placeholder sprites. Red squares for the impact effect, green squares for the ray's visual effect. I will have two timers, one for the timer between impact effects, one for the timer between rays being created, and then as this timer ticks down, once it reaches 0, I will create a new impact effect at the end of each of our ray casts, and I will create a new laser visual effect at the beginning of each ray cast. I have created two classes to control the impact visuals for these lasers, the first being laser visuals, the second being laser physical. I will create a list of laser visuals for the thickness of our laser. So if the thickness of our laser is 3, I will create 3 lists of these laser visuals, these being 3 individual laser visuals, to control the laser visuals that are going to be tracked along each individual ray of the laser. These laser visual classes will have their own list of laser physicals, which is a list of another class, and this class has a value for float distance and a value for the game object we are actually going to be moving through the scene. Every time a laser visual is created for each of our rays, we are going to create a new game object for the laser visual, in this case this being the green squares. We are going to assign it to the relative list of whichever of the rays it belongs to. So if it is being created with the first ray, we'll assign it to the first list of laser visuals, and then we'll set its distance to 0. The distance controls how it is progressing from the base of the laser to wherever the laser has hit, this being a value from 0 to 1, 0 being the start, 1 being the end. Back at the ray itself, as the raycast is fired, it will either find a player value, or it will find a breakable object, or it will find an enemy object, or it will find scenery that it should hit against. Either way, these are going to be stopping the laser wherever it hits, and this can be used to track where the laser's movement should be. For each of our laser visuals, I will run a loop through each of these. I will then tick their distance so it is moving slightly based on the speed value of whatever these laser visuals should be moving at. I'm then going to use a vector-free lerp to lerp it from the base of this ray to the end of this ray, wherever it is hit, by the value of its distance. And then once its distance has exceeded 1, I'm going to destroy this game object and remove this ray from our list, because this ray has reached the end and is basically destroyed and is not needed in the scene anymore, because it's not going to be moving or performing any more actions in scene. Every frame I will be ticking down the timer to create more of these visual effects. Once the timer has reached 0, I will create a visual effect for each of the individual rays in our list of rays. To do this, I just instantiate a game object that is attached to the laser, and I instantiate a visual impact object that is also attached to our laser. I will create the visual impact at wherever the rays have hit. I will create the laser visual at the base of the laser. Depending on what the laser gun actually hits, I will have different information for dealing with whatever it hits. If it hits the player, I will just deal damage to the player. If it hits a breakable object, I will break the object if the object can be damaged by explosions, because I didn't make an override for lasers because they are too specific. And if it hits an enemy, I will also damage the enemy. Enemies are classed as breakable objects, so I don't need to make unique coding for this. I then worked on the actual issue with the laser hitting the player and applying false positives when the player is hit to when they are respawning. This is just an issue with my current coding for how I add respawn mechanics, where the player is positioned in the exact same position they always would be when killed and then immediately moved to another position. The issue with this was, for some reason, the player is registering that they are still being hit by the laser, or the laser is registering it's still hitting the player, when the player is moved back for one single frame when the player is still in the respawning state, meaning the player will be hit by a laser, they will respawn, they will immediately die again, then they will respawn again, and this hit process will be reset. There was probably an easy mechanic to fix this, but since it was an issue relying on my respawn mechanic, and I didn't really particularly feel like changing that because it only applied to this one instance in the laser, I instead added an override to the laser mechanic, so the laser has a hit buffer where it has to hit the player for 5 frames before it can register that the player has been damaged by the laser. And this as a design is actually pretty beneficial for the laser itself. It means it is a hazard that does not kill the player the instant they touch it. There is a 5-frame delay, which is very short, but could be better for satisfying the player, meaning that they can actually interact with the laser for 4 frames before it will actually kill them. This is not enough to actually avoid the laser, but it does apply more of an impact when the player hits the laser to when they are killed by the laser. When the player has hit the laser, this value will count up. If the laser no longer hits the player, this value will count to 0 and then have to be reset again. So the player is hit by the laser, this counts to 5, this kills the player, this ticks down to 0, the player then respawns, this incorrectly counts up to 1, but because the player has respawned and moved away from the laser, this laser is then going to miss the player the next immediate frame, and this value is going to be reset to 0, meaning there is no longer a false positive of the player being killed by the laser. I then added a variant of lasers that would rotate towards the player, these having more of a hazard difficulty around their inclusion in levels, in opposed to regular lasers that would just be focusing on a fixed point. I achieved this with a lerp function, where I find the direction towards the player, and I will lerp the up value of the laser to this direction. One issue of this is that since movement of lerps is not linear, there is an issue where the actual rotation towards the player will be inconsistent if the player is further away from its rotation. Normally, if it's facing the opposite direction of the player, it will take a much shorter time to actually lerp towards the player. An easy way to counteract this is just using a quaternion rotate towards, but I don't like quaternions very much. So I instead applied a modifier where the angle difference between facing towards the player and the actual angle that the laser is currently rotated towards will act as a modifier to the actual speed of rotation. If the player is closer to the actual rotation of the laser, it's going to move a lot faster than if the laser is facing the opposite direction of the player. I then worked on all the actual visual and audio effects for the laser. The laser has an audio effect both at its base and at where the laser is hitting, these both being 2 different kinds of audio loops of lasers, but when the laser is hitting something, this also has a loop of a firecrackle applied to where it is hitting. This is very easy. I find the average position of where the laser is hitting, and I move the audio looping object to this position. this meaning that the audio looper is placed in an accurate position in scene to where the laser is hitting to make this effect. I then work on the actual laser visual effect itself. This is very simple. I have a trail system that is going to be created multiple times to give the impression of a laser. A common technique a lot of games use for laser effects, especially ones used by the player or moving objects, is by having multiple different laser segments that are applied at the same time, created at the same time, and then moved along the scene with the laser to give the effect of the laser being continuous and moving with the object, when in actuality the laser is simply multiple different laser objects being moved. This can be seen very clearly in Elden Ring. If you use one of the laser magical attacks when on an elevator, the player will actually create multiple of these laser objects as the player is moved up or down the elevator, because the lasers are being placed in static placement while the player is actually being moved so quickly that they can create multiple lasers. This gives the impression of multiple floating lasers, but this is really just the visual effect of multiple different lasers being created. For my game, I want a bright and cartoonish laser. I played around with a bunch of different particle effects, but I eventually landed on a visual design where there is the color behind the laser, there is a thinner, bright white color in the center of the laser, and there is multiple spirals going around the edges and in front of the laser, one being the colorful color and one being another light white color. This is just a very glowing laser visual. Next, I create the actual laser impact effect. This is also very simple. I create an array of sparks being hit on wherever the impact effect is going to be hit, and I create a blinding light which is also going to be wherever the impact effect is going to be hitting. This has to be quite large, quite intrusive visually, and also needs to block out the visual of the lasers simply disappearing, because without this effect, the lasers just cut off wherever they hit, and it looks very blocky and rectangular upon their impact position. Next, I have the laser visual and animation. For the visual sprite of the laser, these are firing from mechanical heads. Since the level is taking place in the flying factory, these are just weird mechanical objects that fire lasers. These are either green or purple skulls, depending on if the laser is a rotating variant. And these have a sprite for the eyebrows, the skull head, the jaw, and a screw, which rotates around for the rotating variant. The visual inspiration for these is Lord English from Homestuck, because he also is a green skull and fires a big funny laser. I had a lot of fun drawing these. They are very simple metal objects. I draw metal objects in very similar ways. I just apply lighting to the rims of them to give three-dimensional viewing. I apply scratches to them to make them look metal, and that is it. That is all I do to visual effects for lasers. The actual animation for this is very simple as well. Since these are continuously going to be in a loop, I just have the heads wobble back and forth as if they are actually firing the laser in a weird yelling sort of manner, and shaking back and forth to display the uncontrollable nature of the lasers being fired. Finally, I have the laser lighting. The base of the laser is going to emit a light source of whatever color the laser is going to be, and at the base of wherever the laser hits, in the same way that I move an object for the audio, I'm also going to attach an object to this for a sprite light. This means when the player gets close to the laser's base, they're also going to be illuminated by the color of the laser. This is very obvious as to why I would do this. Lasers are bright, they would probably reflect color onto their surroundings. I quite like the sprite color system in Unity, especially for 2D lighting. I think it looks very nice, and this visual increase in quality is very good. One thing I could do is maybe have a light that adapts its distance and applies for the entire shape of the laser, so it goes from the base of the laser to the end of the laser, but realistically, I don't care that much. And I think the impression of having a light at the actual hit point of the laser is pretty good already, and maybe having a light that is just the entirety of the laser may take away from this visual effect. And that is it for Devlog. The laser system is a very simple mechanic in coding, but is more so difficult visually. I feel like this mechanic was easy to code, but very difficult to actually make the visuals for it look correct in-game. But I am very happy with the results. I have always wanted a laser in Pep-Pel to annihilate her, and now I have such a thing.